It's on. Wonderful. Well, good morning, and thank you very much for coming to my opening talk here. I feel very privileged talking to this audience. I think this is a terrific conference to be at, and I guess I'm overwhelmed. I would like to thank the organizers for inviting me, and I thank you for attending here. So I want to talk about basically scaling, what clouds would do to society and how we can engineer scale in those systems. One of the people that Singapore reminds me of is an architect that's a very famous Chicago architect, Daniel Burnham. And what he said about building anything, including clouds, I hope, make those small plans. They have no magic to stir men's blood. Of course, he went on and he built the Chicago World Fair, and he built many skyscrapers and lots of innovations in cities. So, universities, what can they contribute? I'm from the University of Illinois. I'm proud of some of the people and the enterprises that we have actually created. These are some of the examples of our alumni and what they've created in the world. These are just mainly the ones I chose representing clouds. There's an opportunity here to educate the next generation with the latest technologies and put them in a position where they can leverage the cloud and create exciting new industries. And of course, one of those that always stands out is PayPal for the University of Illinois. PayPal has changed the face of the way we do business. It's based on the cloud. It's based on just an undergraduate that left and wanted to change everything. So, remember, there's sound to this somewhere. So remember that our sons and grandsons, daughters and granddaughters are going to do things which would stagger us. We are looking at a whole new infrastructure for our community, for our world. We're going to look at now at some questions that arise in being able to build the cloud, how to build the cloud, and so on. And these are some of the things that I would like to address in the next few minutes. So the first topic, what's security about? And if you look at what happens with traditional systems, and this is drawn from our knowledge about our own supercomputer cloud, if you like, and about other clouds in our local area, what you find is that there's really disappointing news. The first is that something like 25% of attacks on systems go undetected. So when you're told that security is wonderful, you have to wonder. But again, we can do something about that if we plan ahead and if we design systems with security in mind from the outset. The other aspect about security which disturbs me is that when you look at all the incidents, it's because people have stolen credentials, because people have stolen passwords. It's not because of the software necessarily. It's not because there are mistakes. It's because basically people break security. And we must address this whole issue in the way we build and design infrastructures. We have to design it with society in mind, both the good and the bad. So I'd like to touch on some topics that are very at this moment, you might say, and think about what might happen in the future. Virtualization has created a huge new opportunity. Now, what we're looking at is compute, storage, virtualized resources, a virtualized connectivity, and application middleware services that are themselves virtualized. So we can build very, very complicated logical systems, and they can cover the globe. If you look at what NIST, an American standards organization, if you look at what the European standards organizations are saying, if you look at your own concerns in Singapore and Southeast Asia, what we're facing is the ability to construct really interesting environments that encompass a city, a nation, the globe. We're going to see all of those, and they're going to all interwork together. But to make that happen, you need a huge amount of management, of operations, of interaction, interoperability, of standardization. And those are the key elements. But if you have those, then what you can do is to build a virtualized substrate across all the world that can have all sorts of different organizations. What are you going to use it for? Well, the challenge is to make us all more productive. The challenge is to make us all have more to think about, to do, to play, to have businesses with, to create new enterprise. And I'm going to refer to that as we go on. So what we're looking at is what are the key abstractions we need to make in the world to allow this cloud infrastructure to be useful, to create new activities, to create new endeavors, and to better humanity. Well, managing virtualized data centers, and they're not just going to be isolated, they're all going to be connected together, as Google and Amazon demonstrate. We need to be able to do that on demand. We need to be able to do that automatically. We need to be able to do that so that enterprises can start up and disappear with little friction. That's a huge challenge. We're going to engage the pay-as-you-go, and we're going to make that a really great success for the world. So what is the secret ingredient? And this is something perhaps that has emerged all but slowly from all of the discussions, the planning, the building that has gone on. What we're building are software-defined architectures. And those software-defined architectures themselves are intended to encourage entrepreneurial activity. So you have a cell phone, and you have apps that you can download on the cell phone. You have software-defined networks. HP has opened a software app store for software-defined networks. You have clouds, and there are numerous examples of what you can buy and build on top of the cloud. They're called virtual appliances. And you can instantiate them in virtual networks and create your own infrastructures. That is a true innovation that will change all of the ways we think about things. So software-defined networks. We have endeavored for the last 50 years to build networks. They are, knowing some of the inventors like Bob Kahn, they had endeavored to build a network that was unstoppable, but that everybody could use. And the key was everybody. Networking has become inclusive. Now what we find is the complexities of the systems we build, especially with these virtual infrastructures, these clouds, have become increasingly difficult to manage. The networks are very complicated. We put layer upon layer of the networks. We duplicate what's in the networks. Now we're thinking, how do we remove everything? How do we make it simpler? How do we make it more efficient for enterprise? And the answer has been to define software-defined networks. And the notion is we have a control path, we have a data path. What if what we do is to make it all programmable? And OpenFlow is an example of what you can do. So now you have an infrastructure for the networking, for the communication. This is every bit exciting as the cloud infrastructure. Every bit as exciting as the virtualization that's going on. In fact, it's virtualization of communication. What can we do with that in combination with clouds? What you find happening is people talk about slicing of networks. But they don't stop there. They start talking about slicing of clouds, of having a slice through a particular cloud for a particular purpose, of integrating and federating different parts of the cloud in that slice, like creating auditing systems, like creating authentication systems. So we have developed techniques which go way beyond what we actually have applied. We can produce authentication systems for the world. We can do monitoring of a particular slice for the world. But we have to deploy it. We're back to Daniel Burnham. We should be thinking great thoughts. So we've created our first, well, perhaps it's not the first, but it's certainly the most dramatic set of platforms to operate. The OpenStack Cloud Platform is open source. It's taken the best of breed from all sorts of different places, from Amazon, from Google. It's integrated it together and it's made available to everybody. And what you can do is to create your virtual appliances with your virtual network, with your virtual storage on a tiered storage system, independent of the hardware, and you can deploy it elastically. You can create whatever organization, whether you need a small one or a big one, whether you want to create an Obama campaign for the next election. The facilities are tremendous. And of course, along with that is the notion of applying security and thinking in terms of security for those creations. So if you have a slice through clouds and networking, it doesn't have to communicate to other slices, even though it shares media. We have learnt encryption techniques that can partition your cloud into pieces. We have tremendous resources. So here's a quick introduction to OpenStack and networking. There's software called Neutron, and what Neutron does is it connects up OpenStack with software-defined networks. So you now have glue. If you want a 1,000-node network organized, say, in a ring, you can just instantiate one. If you want to expand it to 10,000 nodes, you can do so. If you want to apply hashing to that network to get it fast storage, tiered storage, you can do so and you can scale it. You can engineer it. These are huge benefits. I challenge you, who's going to be the first to make really big companies based off these technologies? So what about what we're going to use it for? Well, the first thing you find is that you build very, very big data sets, huge data sets. Those data sets behave differently. What we're accustomed to is thinking of Windows, Apple, Linux file systems. They have characteristics that they don't follow what we find in big data. If you look at big data, and we can look at Yahoo, which is local to us, We can look at their traces and see what they do. What we find is that they use data in a totally different way. They partition it into chunks so they can actually parallel program it. They produce those chunks and have metadata to describe them. The metadata gets huge. The metadata becomes very important. Suddenly, you're counting how often you use those metadata objects. So, in summary there, you've got enormous file churn in big data. You have files and you need to know about their popularity. So say 80% or 90% of the files are accessed so many times. They don't behave like traditional files on your laptop. There's a small percentage of them that are really highly popular. And you have young files that you need to make sure they're accessible for your algorithms, for your processes. There's significant inactive storage, so you need to go and find it before it swamps you. So all of this has implications. We have complicated relationships with the files, with the processing. We need to think very, very carefully about how we build these systems. We need better models of these systems. We need to understand their properties so we can exploit them. We need to understand those properties for caching, for making things really fast, for deciding where to place them in tiered storage. We have a wonderful opportunity now because we can recognize the future. That future can encapsulate big data and use it for humanity, and we can take all the advantages of what we're learning to build much better systems. One of the aspects is, what about our traditional database? It's slow. We need to go 1,000 times faster, so we're going to look at NoSQL databases, but they're wrapped up with this whole problem about consensus. We run things, consistency. We run things, and if we ask for transactions, everything is slow because of the protocols. But we also know that we can run things and have eventual consistency. So you find Paxos and Zookeeper sort of dominating some of the things that Yahoo and Google are implementing. These are important assets. We've got to exploit them. We want to build the databases of the future. One of the aspects that isn't paid attention to, but the universities can help, I believe, is just how correct are these massive databases. So if you take, for example, Cassandra, you look at the consistency models, and it has layered consistency. What you find is a very complicated system, a very complicated set of protocols. And if you model them, what you find is that there are problems within Cassandra, there's problems within a lot of other systems. The universities need to be able to help to iron that out, to make the path smooth into the future. We have a lot of work to do. So where's the cloud hardware going? Well, if you follow HP, IBM, or Intel, what you find is we're all going towards persistent memory. HP would say Memristor. There's other alternatives. What that is a persistent memory. You no longer need files on a disk. You don't need serialization. That change is just down the road. It's going to be a huge impact on the way we build systems. HP is right. You should design operating systems and distributed operating systems and cloud systems for it, because it's going to be very disruptive. We have high performance interconnects. We can build 100 gig networks around the world. We have one in the United States. We're going to interconnect those 100 gigs. Those will go to 5 or 6 terabits. That will provide us fast connectivity from your mobile with cut-through routing using OpenFlow to get to these data centers. Huge impact on the way we use systems. It will enable us to drive cars without drivers. It will improve productivity, distribution systems, massive disruption, but huge economic possibilities. So, I can imagine a tremendous innovative use of advances in clouds, and I've just listed a few of them here. It's going to be coupled with another invention, the Internet of Things. It's been difficult to get off the ground. I did research on this in 2000, but we weren't able to do it because the devices were so expensive. But now they're not. Now there are huge amounts of sensors out there, and we need to gather the information, put it together, analyze it in our cloud, produce value for humanity out of the cloud. We can do it, and it's a tremendous opportunity. It allows you to build things like smart nations. What is going to be a smart nation? We need to define it. Again, going back to Daniel Burnham, think big. Because this is really a radical change in the way we are operating as a community, as humanity. There are enormous opportunities. Now, of course, cloud computing is a young element. Universities hold a responsibility to educate and to inform. One of the things we must do is to go out and tell the world what cloud computing can do. What is the vision of the future? So we're putting together courses. My own university is putting this Coursera course, MOOC, on cloud computing, and it will be hitting the streets or the networks next spring. And what we would be doing is inviting everyone to go and write their own cloud, create their own cloud stack, create their own network, and deploy it for some use as a sort of exercise in that class. Thank you.